Hi everyone. So this topic is thread communication. So we are going to have two main objectives. First is passing data to thread. I mean, that we know already. When you create the thread, we use the function to that this function will be executed by thread, and we know how to pass the argument also, like in a comma separation list. Okay, so we know how to pass data to a thread. The next will be the main focus of this chapter, which is the receiving data from the thread. So how to receive the data from a thread. Okay, so this is called inter-thread communication. And for inter-thread communication, we're using a single-use channel, which is the promise in the future. So sender is going to receive the promise and will set the value of the promise. And the future is linked to the promise, and then the receiver, for example, the parent thread or the main thread, will call the future and will use the get function from that. So from the future object, it will call the get function to get the value set by the promise. Okay, so first is passing arguments from parent to worker thread. So means that we're creating the thread and we're passing some data to the thread. So which is very easy. So we can create, for example, that's the process order. And that's the order ID. So we want order ID to be processed by a thread. So this is a function. This is a simple function and a regular function. We have the process order. It receives the order. It processes the order. Maybe it takes 1 second to process the order, and then it says that this order has been processed. Right. So we don't want to block the main because we have to process other customers as well. So we are saying that this process order should be executed by a thread. And for that, we can create a thread here. We can say main, this is the thread one. This is executing the process order. Maybe the order ID is 123. Similarly, we can create another thread for T2 that will again use the same function, but this time the order ID may be different, right? And finally, before exiting, we can say that join all of these threads. So that's the one way to process to pass data. So this 1 to 3 is the data that is passed to the thread. Okay, so if we have more arguments, so we can write comma and other arguments. If we don't need a process order, we can have a lambda expression as well. So we can say that that's the main. So F1 is a lambda expression, or we can copy a closure. So we have the no local variable, and we're passing the variable to the lambda expression, which is the order ID. And again, it's the same. So we are still creating the thread. We're passing this function here, a lambda expression here, and that's the value that we want. That's the order ID. And it says, does the work, and it says this order has been processed, right? So this is one, or we don't need F1. So we can just shift all of this here. Okay, so or we can pass, I mean, or alternatively, so for example, here it is being passed here, but we don't need to pass here. It can be captured here, provided if it is a local variable. So in the next, actually, we have a local variable order ID 1 to 3, and we want this order ID to be passed to this lambda expression. So in that case, it's not here, it's here. Right, so we can capture it in the capture list, and we don't need to pass it here because it's already been captured. The value of order ID will be passed here, and then we'll get the order ID 1 to 3. Okay, so passing argument from worker thread to the parent. So that's what we want to discuss in this lecture, that how to pass arguments on from the worker thread to the parent thread. So reverse from worker to parent. So we pass parent worker. And for that, we'll use the single-use communication channel. So that's the first way. There are other ways also. The first very simple way is that I don't know whether it's simple or not, but that's the one way that we use the library called future, and we have two objects, standard promise and standard future, and we need to link these two objects, and then it becomes the single-use communication channel. And the design principle, which is based on these two objects, are it's the single producer. We call this single-use communication channel. So we assume that there is a single producer. Single producer is the promise. The thread is the producer that produces the value, and that needs to be sent to the parent thread, which is the consumer that will receive the value, and that's the future. right? So standard promise can store values or the exception as well. So we can call set value or set exception on the promise. So promise can store values or the exception that can be acquired asynchronously by the standard feature. So the main thread doesn't need to wait for this that thread to execute. So main thread can acquire whenever the main thread wants. It can acquire the value asynchronously using the standard feature, right? Let's see how it actually works. So we have a time here, seconds, 1 second. So again, we have the process order, right? So it's receiving the order ID, still same. But now in addition to that, from the main, we'll create a promise object and we'll pass that promise object as an R value. So we'll move that basically. So we'll use the move semantics to move the standard promise from the parent to this thread. So now this thread receives the promise. Okay, so the only thing that it needs to do is set value. So it needs to compute the value, whatever value we want to pass. So currently this promise is of string type. So we are saying that it receives order ID and the promise is of string type. So the promise string type means that this thread will do some work and will set a string in the promise, right? So this is what it does. So it says p status, which is this promise status dot set value, and its status is a string. So it creates a string which says processed and this order ID. It is a string, so it says that this order has been processed, and then it sets the value to this string. Now, if we want the process order to return an integer, then we say standard promise integer. If we want double, then standard promise double. So whatever we want from this thread function, which is the process order, so the promise will be according to that. And then we can call set value and set that appropriate value for that promise, right? So this is what is the basic thing that we want from the thread. So we'll give them the promise and it sets the value. Very simple thing. In the parent, first because we have to pass the promise, so first we need to create the promise. So that's the promise object, which is a standard promise because we want string from the thread. So it's a standard string. And then we have the promise, and then we are creating the future. The future is also of string, so they should be of same type, right? So it will set the string and you'll get the future. Thread main will get it from the feature, and then we'll say this is the feature one object, and now it's linked with the promise. We'll say promise one dot get feature. So promise one dot get feature has been assigned to the future one. Okay, so this is how we have linked these two, and now we are saying that create a thread, use this process order. These are the arguments, and then use the standard move. Okay, so promise one has been moved to this because we created this function process order. Process order needs two arguments. The first argument was order ID, and second one was the promise, which is the R value reference. So we use the move semantics to create its R value reference and that assigned to that. And then the thread function can set the value promise one, and then here we are saying future one dot get. So future one dot get future, the main thread will execute this and will block it until the data is available. Block means it's possible that the thread has not yet set the values, but the future is future called the get first. So it's possible, right? So the blocking means the main will not proceed further. It will not join or will not do the task until this get returns the data. Means that until the data is actually set by the thread and is returned by from the using the get. So once it's there, so dot get will give us the process that order ID, because this order ID is currently 123 that we have sent. So it will display standard cout. It will say processed 123. Okay, and you can also have a reference also, but the R value reference is much better. And in the process order, for example, I have given here the reference as well. So instead of R value reference, we have a simple reference here, and then we can still set the value, and then it can display this process order ID. There is no change here other than we are using the standard ref instead of standard move, because if that's an R value reference, we need to use standard move. If it's a reference, then we need to use the standard ref here, right? And get we can still get will still block the data as available, and it's still the single use channel. So you can't use the same promise and same future for any other thread. So if you have another thread, so then you can create another promise to future 2 and then link with that, and then promise to give the promise to that thread. So if you have number of thread, then you need to create multiple promises, multiple future, link all of those promises and future, and call the future dot get on all the vector of futures. So that's possible. We can do that if there are number of threads. So parent thread, to create thread using the, we can use the lambda function as well as we're talking. So instead of writing the order function, we can just have a lambda function also. So here we can say the process order is an this our lambda expression, and we are passing this an order ID. Order ID has been captured, and promise one has been uh, passed as a reference to this. And here we can use this one and still we did some work, and it says processed, created a string, and finally this promise one is by reference, and we set the value to this promise, and then we can in the, this is a lambda expression, and then we pass this lambda expression to T1, right? So this T1 is a thread that will execute this lambda expression. So we can remove this one completely and pass this complete here also as a lambda expression. So anyway, so this is the thread T1, and then we can use the get function to block this main and get the data until when this set status is available. So we will get this data, and then we'll still see processed 1, 2, 3. So this is without lambda expression. So we created the thread T1 and we passed this complete here. So order ID has been captured, promise 1 has been captured as a reference, and then we can set the value, and then we can get it using the dot get. Okay, so the difference in promise and the future is, like, promise is to set the value and the future is to get the value. So promise future are one-time communication channel. Like we have single producer and single consumer. We have one thread, and one thread set the value, and the main thread is the consumer. If we have second thread, which is the second producer, then we need to have another promise, another future. So it's used for one-way communication. So this is only used from the thread to the main. It's not the from thread from main to the thread. It's used for one-way communication channel from child thread to the parent thread. Pass promise to the thread function. So we are passing the promise to the thread function using standard move, and it enables thread function to send back the message. So we, in the main, basically the parent create a promise first, promise object, and then pass this as a standard move to the thread so that it can set the value. So ownership is with that, or we can use a reference also. Okay, so what's the behavior of set value and get? Set value is called on the promise, get is called on the future, right? So get blocks, but if the set value is called before get, right? So get will block, so get will not able to, will not allow main to proceed the get till its value is available, right? But if set value is already called before the get, then it is not blocked because the value is available. Right? So set value is called before get, returns it, but it returns immediately since the promise is fulfilled and the data is available. Like so, if your set value is called earlier before you call the get, then it's not blocking. So it's continue. It returns. Alternatively, we can also use the wait for, because if you think that it's going to, the thread will take time and you don't know how much, then you can try, because get will block. So if you want to do some work for a, maybe you think that get may take so much of time, but I want to check when it's available. So for that, we can say wait for. So let's say that we have two times, time 5 and time 1. 5 is 5 seconds and the time 1 is 1 second. The process order, so what I've done is that it still receives the promise, and it sleeps for 5 seconds actually. So 5 seconds, it needs 5 seconds to process the order. And then it says that's the string and it sets the value, right? So this thread will take 5 seconds to process the order, and then it sets the value. It fulfills the promise. And now in the main, we have this order ID, and we created this promise one, and we created the future one, and we linked them. The future promise one dot get future is equal to future one. So this is how the channel has been created. And here we created the thread here, and the process order is we pass, order ID we pass that this order to be processed, and we also move the promise one so that this move the thread can set this promise one its value when the order has been processed. Okay, now that will take 5 seconds, but main will continue, and main will say status, main will wait future one dot get wait for this. So immediately main for go for this, but it's wait for, right? So it's wait for time one, which is the 1 second. Okay, so in 1 second we know that the results will not be available because thread definitely will wait for 5 seconds. Okay, so there are high chances. So it's possible that our wait is 1 second, but it's possible that CPU may not give us for the 10 seconds also. That is also possible. And but there's a very low chances, right? So it's wait for 1 second. So it's wait for 1 second and their time is high. So we can check its status, whether the data is available or not. So if say we say if status is equal to standard future status is ready. Okay, so if the standard future status is ready, then if this status is ready, it means the data is available and we can call the get. Right. So in the wait or wait for, we need to call the get. It's not automatic. In the get, the wait is automatic, right? So if we have said wait, then we need to we can only know that data is available, right? So but we need to call the get again. So if this status is future status ready, then we can call the get. Otherwise, we can say the results are unavailable, and we can, if you want, we can do some other task as well. And once the task is done, and we definitely have to wait for the data to be available. So we can call get or we can call the wait. So let's say that we call the wait here. So wait will again block the data till the data is available. So it will, when the data is available, so the main will execute this statement, which is the get now. So now you can get the data, right? And then you can finally join. So the only difference is that if you don't write the wait, you can just write the get, and get includes wait. So get is going to wait as well as get you the data, and that will be printed. But wait is just wait only. It will not give you the data. As you can see, there is no return type here. So future one dot wait, and then we can have the we need to get the data, and that we can display using the standard cout. Cannot be used standard cout on the wait. Okay, and finally, if you run this program, you will get results unavailable and do some tasks and processed 1 to 3. Okay, so now let's say that we have an exception from the worker thread, and we want to display the exception also in the parent thread in case there is an exception in the worker thread. Okay, so now we do need 1 second only. And in the process order, what we've done is that we want to check whether the order ID is negative or not, or 0 or not. So if it's less than or equal to 0, for example here, so this will throw an exception, throw runtime error. And technically, we're not throwing this error directly to the main. So we are sending two values. Either the set value when it's greater than 0. So we'll say this thread do some work, set the string and set value, or we're setting set exception. Only two things, either set value or set exception, right? So if it's less than 0, then it will throw the error and the exception will be set. So if it is not less than 0, then set value will be set and the exception will not be set, right? So that's our process order. So either we set value or set exception. And in the main, we can have, for example, here it's positive number 1 to 3, and we still created the promise one. We created the future one linked with the promise one, and we passed process order ID, and we moved the promise. And in the try catch, we can check future. We can try the get also, because we know that this get function can return an exception also. So we must have in the try catch. So if it doesn't return, then it prints. But if it returns some exception, that will be caught here and then will display what. So if it's a positive, so we can say processed 1 to 3. But if it is negative or zero, then we'll say invalid order ID, because then this exception will be caught here, and then we'll get the description here. Ending data using async. So that's one way of creating. So what we have done so far is that we are creating the thread using standard thread. We create the thread, we pass the promise, and we get the feature. And we future is already linked, and then we get the using the future we get the value. So if it's a vector of thread, then what we do is we create a number of threads here. It's a number of promises and futures, and then we will create a vector of threads, vector of promises, vector of futures, and then from that vector we'll link those uh, promise and futures, and then we'll pass one of their promise. If we are creating T1, then we'll say promise 1. If we are creating T2, then promise 2, because we need to have promise 2 is linked with automatically we'll get future of the future 2. And then we have, maybe we can write in a loop that this is a thread ti which is linked. We move the promise I into that. So we did a number of times, and then finally outside we can have a vector of futures, and we'll block everything future1 dot get and keep displaying everything here, right? So this is what we can do. So we need to create number of promises, number of futures. So async is a different way. So in async, we don't need to create the promise, only we get the future directly. The promise is created internally. So promise future involves a lot of code. With async, we can simplify it further. So, and in the async, we create tasks. We don't create threads. So, and we can control the concurrency. So what's the difference between the thread and the task? Threads may sometimes not improve runtime performance and can reduce the performance even. So if you create large number of threads, your performance can decrease even. If you increase some limited number of threads, then it's better, but we should not be creating large number of threads. And we'll see an example when we increase the number of threads, and then when we have lower number of threads, what's the benefit? And calling async, so we use the async here. So calling async generates a high level task. So when the system decides whether to run parallel or synchronously, right? So synchronously means that it's all sequential. So one execute, then second and third and fourth, not parallel. So either it's run parallelly or synchronously, it's decided by the system, not by us. So we as a programmer decide only one thing, that this can be parallelized, right? So we're not instructing anything here. So we say that the code executed by the task can be parallelized. In principle, it can be parallelized. Okay, so standard thread versus standard async. So we have used standard thread, that create a thread, pass the promise to the thread, and the promise set the values, and we get we can get that value using the feature. In standard async, so we don't pass any promise, it's a regular function, it returns values, and that return is the future, and we get that feature. So standard thread creates thread, while standard async returns the future. So it creates the thread, it just gives us the future. We don't have to create the thread, and it gives us the future. Standard async calls the thread destructor automatically. And further, we don't have to join also, because the thread was not created by us. So thread in the standard thread, we create the thread. In standard async, we get the feature. And we don't create the thread, so no join is needed, because we don't have directly the threads. So this also reduces the concurrency bug that you forgot to join. Okay, so no standard promise needed for standard async, no promise required, since it returns the standard feature, right? So compiler creates standard promise internally. So and we can control the concurrency with standard async options. So there are different options in the standard async. We'll see in the next slide what are those options. And we can control the concurrency, like we really want concurrency or not, or we don't want concurrency. So it's just option. We don't have to change the entire program, that in case we don't want a particular part to be concurrent, right? So with that option, we can use this, that so in this now I don't want concurrency with just one minor change. That's the option. So threads have overheads. So threads can have overhead, and choosing option to let the system decides the concurrency can improve the runtime. So we can improve the performance in case we want system to decide whether this should be a concurrent or not. So these are the three options for the standard async. The first option is standard async is deferred. Okay, standard launch deferred, right? So then we'll pass. So that's the, if you call the standard async, so we'll call this standard async, and then we'll pass the first option that I want deferred. Second function name that should be executed by the thread that we want process order, and that's the order ID to be used for this function. And we don't need to pass the promise because this is standard async, like we don't create promise. So we can, if we, it's a vector, then we still need to create a number of it's a vector of futures, but not a vector of promises. And this is synchronous. Synchronous means since it's a deferred, so it's a synchronous, not asynchronous. Okay, so now if it's an asynchronous, second option, so it's same standard async, and now we'll say standard launch async. So right, it's still same function name argument, and now we'll, since the option is async, so this is an asynchronous. The threads created immediately when this statement executes. Threads are created. In this case, thread is not created, so it's deferred until either wait or get is called in the future. And async has another third option, which is any. So in this case, system decide whether the threads created now or maybe at the later stage when get or wait is called. So get or wait is called means when the result is actually required by the main. So let's say that we have five numbers, not five number, 25 numbers, right? So let's say that we want to add these 25 numbers. And threads, we created five threads here, and these five numbers are stored in different, given to different threads, and they compute the sum of these numbers and then return that sum, and that sum will be automatically, because this we are using standard async, so it will be a vector of features. So we'll get the result in future 0, future 1, 2, 3, and 4. So we'll get 5 futures, no promise required. And main will collect the results using get from the future and then add the sum to give you the grand sum of the all these 25 numbers. So that's our program, and we'll compute the time as well. Okay, so now we are going to create a task. Actually, not the we're not going to create threads, but rather a task. That's a high-level task using the standard async, which returns the future. As you will see here, this is our process function. It receives the data, which is the data chunk of 5 numbers, and it uses the accumulate from begin to end, starting from 0. So then default is summation, and we get the result and return the results. And it can throw exception also. We don't have any changes here. This is our regular function as we have been writing so far. So this is the same function, same format function, no promise, no special treatment. So this is directly executed by the, this is a task for using the standard async, and then the system decides whether we need to create a thread now or later, and depending on our options as well. Okay, so now we are using the standard async in the main. So that's the main, and in this we have this data. Right, so this is the vector of integers. So that's our data. So there are 5 data sets, and we started the time here. That's the T start, which is the standard chrono high resolution clock. And now, so we got the time. And this is a standard vector of futures. So we still need vector of futures, right? So we created the standard vector of future because in this case, our return is integer, not the string, right? So since it returns this integer, so our future will be of integer. And then it's a vector of futures. So it's a vector of future, and this future is of integer. And that's our futures vector. And we created the 5 threads here. We have 5 data sets, and we have 5 here, number of threads. Okay, so now we can start the loop here. Or we created 5 threads. For 5 times loop will be executed. And standard async returns the future, right? It doesn't return a thread. So standard async create the future, and we are using here the deferred option. So deferred means that don't create the thread right now, and when it's actually required. So, and when will be actually required? When we'll call the get or wait. Okay, so because then our main can't proceed, so the result is required. So standard launch deferred, and that's the process functions to be used. And we have passed we converted since standard cref. So cref is because our this is, it receives the constant reference. If it's a constant reference, it receives the constant reference, then it's a standard cref. It's receiving by copy. You can pass by copy as well, doesn't matter. So, and then we don't need to we don't need to convert to the reference. If our process function does not receive any reference or a constant reference, we can just say that this data I has been passed here. Okay. So anyway, this is the standard async. So we pass the option, we pass the function, and we pass the arguments to the function. Okay, we got it. And then this is a future. This is one future, and we can say future and plus back and move this future to the vector of futures. So now we have a vector of futures linked with all of these threads. Right. So linking future creating a vector of future doesn't mean that all threads have completed. It's just that it shows that we can use the future dot get to get the values returned from the our thread function or the task function. Okay. So now we're saying future dot get. So we created it from for vector of futures to we pick one feature with ampersand is important because future can't be copied. So we'll say for reference future, so we get the future dot get. So we call the get, and this get will return the sum. If it's not available because it's deferred, so it will create the thread. The thread will compute the sum and will add this sum to the zero. Again, second feature, our approach is deferred, so the result is not available. Now when the get is called for the second thread is created, the sum is computed, and the thread runs, right? So you can see that this is perfectly synchronous. So we have not created, the thread were not created earlier and now being created when we call the get one by one. Okay, so we called 5 times get, so one by one all of these 5 sums is computed and this sum is stored here. And now we can stop the time now, and we can compute the duration by subtracting the t end minus t start minus count, and then that's by casting it the duration count, right? In terms of microseconds. So we get the value of sum and we get the time, right? So that's the time taken. So in my case, and the sum is 325, which will be exactly same in yours also. The time is 8 microseconds. So maybe in your case, maybe less or high, depending on the system and the environment. So, but that's the standard async gives us. So it takes 8 microseconds. Comparison of results. So in case we want to compare of different options, for example, this is standard async with the deferred. So if we use the deferred approach, then it takes 8 microseconds. If we use the async with the async approach, which is the create the thread now, then it take 45 microseconds, even higher. So if you use the effort, deferred is much better here, 8 microseconds only. So this is called deferred, means it's lazy valuation. It doesn't do any work. So it does only when it's required. Okay. So may save time in some cases only. If any system dependent, 86, but it looks like they are very similar. So it means that the system is using async for when you call the any. Okay, so now let's do the same example using the standard thread. And how do we create this trend? So right now, as you have seen, the process order does not receive any promise. It just is a regular function, but we get the return future from the standard async. Standard async return future, and then we add that future, move this future to a vector of future, and we get a vector of futures, and then we call from that vector of futures, we call the get, and we get the results. But if we have to use the standard thread, then what we need to do is we need to create a vector of promises as well, 5 promises. So this process function will need an R value reference of the promise. Okay. So in this case, we are a promise, and now in this case, it's an integer promise. Like this process function will set a value of type integer, and that's what it does. It still computes the value, and it says promise dot set value, and that's the value here. That's the result. So it sets this value, and now this value will be retrieved using future dot get. Okay, so in the main, we have this data chunk of 5 data sets. We have C start, we created 5 threads, and we have this thread, and we have the vector of futures, right? Okay, so now there is one improvement. You can have a vector of promises also, or we can have every single time create a new promise, because you are not going to use that promise anyway. But future we need to use, because we need to call the get on the futures. So outside this loop. So there is little improvement here. So we are creating the promise, only single promise, and every time we are creating in the in this loop. So we have moved this promise here, not before that. right? And this promise, and we are linking this promise with the future here also. So we're directly moving this future here instead of creating a future and then linking it with. So what we've done here is we created the promise, we linked with the get future, we got the future, and we move this future to this vector, right? So that's what this task does. So we did it 5 times. So, and then once we linked with so we have created a single communication channel between the newly created promise and with the future. And now we can create this thread. So standard thread, the thread is created. And in this, we pass this process, which is the function, and then the data using the standard reference, C reference, that because it expects. And then we need to move this promise here. So this promise is moved, and we have already linked its future with this future. So everything we can get from the futures.get. Okay, so that's there. And then threads.m+spec. So we can and move this thread to the vector of threads also. So because we need to join the threads also. In async, we don't have to join the threads. Right? The threads are explicitly not created by us, so we don't have to take care. But in this case, we have created the thread, so we have to do two things. First, the futures we need, and then threads also we need. Okay, so we did the sum, and then for each future, we did future.get, and that's the sum here. And then finally, we join all the threads for auto or ampersand t threads and t.join. So we join, we have the future, so it means that this sum should be the total sum. And now we can stop the time, that the t end here, and now we can get the duration here, that's the sum, and that's so this is with the standard thread in case we want to use it. And it took 125 microseconds, which again is not very good. So we can see the deferred approach works very well in this case. So what's the difference between standard async and standard thread? Standard async seems better than standard thread. First, you don't have to create a number of promises. I mean, we can still avoid the number of promises, but we still creating a promise, passing to a thread function, and then it sets value. While in standard async, we don't create promise, we just have a regular function, it just returns, and that return is the future for us. And second, it gives more control. So we can set, if we don't want concurrency, we can just say deferred. If we want concurrency, then there's only one option. We don't have to change entire code. So standard async gives more control on the concurrency, and living into the system help optimize the performance. And the programmer decides what can be parallel. So we just create tasks with the standard async. So if the tasks are better. The difference between threads and tasks. So threads handle latency. So threads prevents main program being blocked and allow the program to perform other tasks while waiting. So that's the main advantage of the threads. And the tasks are mainly on the throughput. So we want overall system performance to be better. We are not concerned about whether this has been actually done parallel or not. We are concerned about the total output, the total performance should be better. There should be always the less time, and more tasks should be done. The task in throughput, it focuses on executing many operations in parallel and enhances the overall performance. There are two, let's say that we did two experiments. Let's say we do two experiments, that's what I have done. So let's say that we want to add numbers. And to experiment one is that I fix the number of threads, but batch size vary. Batch size means the data size vary, right? So I have a number of threads, 5, and in each thread, we're giving 10,000 numbers, maybe 100,000, 1 million, or 10 million. And experiment two is the threads vary. The data size is fixed. It's always 1 million numbers, and the threads are it's less to high. So we have 10, 100,000, and 10,000 thread, and we'll see that how is the time taken by this competition task vary. And batch size per thread, because it's data size, total data size is 1 million. If the 10 thread, if there are 10 threads, then 1 million by 10 will be the batch size for per thread. Similarly, if we have 10,000 thread, then we have 1 million divided by 10,000. That will be the data size by number of thread. That's the batch size per thread. Okay, so let's say experiment one. So we have 5 threads and 10,000 data size. We have 10,000 numbers, and 10,000 numbers are not 1, 2, 3, 10. All are 1, so for simplicity. Okay, so, and we know the sum will always be 10,000. Okay, so that's our process function, and we are using standard async, not using standard the standard thread. So since we're using standard async, so we are not passing the promise here. So it's a regular function. It receives the data, it computes the sum, it returns the sum, right? So that's the result return. Here we have this 5 threads. We have 10,000 batch size, and this is the data. And we assign this data assign batch size 1. So that's a vector of integers, and we said that this vector has 10,000 numbers, each equal to 1. Okay, so everything is 1. And we created a vector of futures. So this is a vector of futures, and that gets the integer because our this function returns integer. Process function return integer. So that's why we have the future as an integer. So that's our vector of future. Now we can start the loop. We can start the timer also. We can say for I up to n threads. So we created how many threads? 5 threads. And in this, we call the standard async. In the standard async, so we will change options. Now first we are saying async. Okay, so that's the async process function. And we're passing the data to this one, right? And this data is the all this 10,000 ones. So that's what we pass this to data. And this will return the sum of these numbers as a future. And then we can say, move this future to the futures vector. Okay, so this we got the futures vectors now. And now we can say that future dot get outside this loop. We can call futures dot get so that it's available to us. So we say sum is 0 and we'll say future dot get and add to the sum. So with this, we have the sum from all of these vectors. Okay, so all of these 5 vectors received this data, which is 10,000 numbers, same data to all the threads, and we get the sum may be 50,000. Okay, so we got the sum of the numbers from all the threads. Okay, so we pass 10,000 numbers, 10,000 ones to all, and we get this duration, time, and this one, sum and time. In this case, we get, when we do the experiment, when each thread batch size is 10,000, 5 threads receive 10,000 data each, and then added the total. So if you use the async option, it took 131 microseconds. When I use the deferred, it took a very high amount of time, 488, right? So the asynchronous, you can say the speed up it's 3.73 times. It took higher time. So just divided with this one. So it took higher time this one. So this is the high speed up. Similarly, when it's 100,000 data numbers given to all the 5 threads, so we are receiving 1.7 times asynchronous speed up. Okay, so we have 5 threads again with 1 million numbers, we get 3.34, 5 with 10 millions, 4.7. So we can see it here that as the numbers are increasing, the data set of each thread is increasing. If we still have the total number of threads 5, the speed up is increasing. This is just maybe very different, but in general, it's you can see it here. 4.7 is very high from this one, so it's increasing. We can say that. Now we'll do different. We'll change the threads. We in this case we change the data size per thread, right? So in the next case we have total data size is fixed. Let's say we have only 1 million numbers to be performed by all of those threads, and we are saying that the one first case we'll create 10 thread, then 100 thread, let's say, because 1,000 threads, maybe the data will be less per thread, and then we create 10,000 thread, our data is just 100 per thread. So we have more threads but less data per thread. So which way is better? So, and we use the standard async also and standard deferred also, right? So in the standard async, it took 552 microseconds and deferred took 7,000 microseconds. So speed up is 12.8. So this is much better, 12.8 times better than in standard async than the deferred. So async is highly better. So as we increase the number of threads, we can see it here that standard async is taking much time here. So it's 76,000 microseconds, and deferred take 10,000 microseconds. So the key takeaway is here: the standard async is also it's 12.8, and it reduces to 0.1. In fact, it's less than 1 now. So your deferred is better. So we should not be creating high number of threads with less data. So if you're creating thread, then those threads should have sufficient data to be performed. Otherwise, just use the deferred. Don't create the thread just for very simple tasks. And that's what we have seen it here, right? Okay, so now standard async or standard thread. So the guidelines is that standard async for simple and easy task. If you want to use multi-threading, so use standard async for any task, but standard thread because we need to create a promise, link it with this. If there is really requirement that you need to should do it, then for some complex cases we should use standard thread. But in most of the cases, standard async is better. So now, next topic is the data race. We'll cover this in the next lesson, but on a very high overview of the data race, so we need to avoid the data race, right? So what is data race? At least two threads accessing the same memory. So we have a memory and at least two threads are accessing the same memory and one is modifying. If you both reading, doesn't matter because both will read the same, but if one is modifying, then it's a problem, right? So data being updated may not be meant to be read, and we'll see an example how this can create a problems, the data races. We need to avoid that. What are the safe ways to avoid data race? First, synchronize the threads using join, right? So you created one thread and then say join. Thread should wait. Second thread, again, before since it is joined, then you can create a third thread. So it's a proper synchronization. That may be one way. Use promise future, like the thread should not read the value. Thread should get the value using argument and should return when it has completed, and then only main is getting. So once main gets, then it passes to the next thread. So we use the promise future to get the result, right? So we're getting the result, or it's not that we need using async also, it's still the promise future. So either use standard thread or use standard promise. The topic is that the point is that we need to use the future here. So we are using the future to get the result. So it's not that the variable is shared directly between the threads, right? And then or pass copy of argument to the thread, or don't pass the reference, pass a copy of the argument to the thread so that it is not updated. The problem is the data races when you pass the mutable data to a thread that can be modified and you created multiple threads for that. Right, so one thread is modifying the data and other thread is reading the data. But if you have passed the copy of the argument, then the thread is not going to copy and other threads are also not a problem for that because it's any modification done to is their own private copy. So when passing complex data structures, objects with pointer variable, use copy. So in case you're passing the objects to the thread, then we need to use the copy or move semantics carefully. Either create the deep copy or use the move semantics so that it's the decision rules are very much clear and that how the data will be modified by the thread. So these are some of the safe ways to avoid data race conditions, but we'll have some other ways to in the next lesson. Thank you.